Okay, everyone, we're going to take a look at 7.3 slope point form of the equation. In this introductory video, we're just going to take a look at developing the equation or the formula. And what that means is we're going to take information that you already know, and we are going to manipulate it algebraically to arrive at the formula that you are going to be learning about in this section. So the slope point form of an equation is the equation of a non-vertical line in the form of y minus y1 equals m times x minus x1, where m is the slope and x1 and y1 are the coordinates of a point on the line. The reason why it's non-vertical line, because if you recall from earlier lessons, vertical lines do not have slopes. Their slopes are considered undefined, and because this formula uses slope, it will not apply to vertical lines. Okay, and the other thing I want to draw your attention to is that we have an x1 and a y1 as our coordinates. Those are a given point on the line. Okay, so the slope of a non-vertical line can be determined using m equals delta y over delta x. Okay, we've seen this earlier in this lesson. Actually, we saw it in our last chapter. Delta y, if you recall, means the difference in y, and delta x means the difference in x. So if we have the point x1 and y1 as a given point on our line, then x, y can represent any other point on the line. So what we're going to do is we're going to substitute those 2 points, so x and y, and x sub 1 and y sub 1 into our slope formula. Okay, so we're going to substitute the coordinates of these 2 points into the slope formula, m equals y2 minus y1 over x2 minus x1. Okay, and essentially what we're going to do is write up a formula for slope specifically for this given line. Okay, so why don't we look at the line and then we will take a look at our substitutions. Okay, so on our graph here, if you look at our coordinate here, then this is y sub 1 and this is x sub 1. And if we take a look at this coordinate, then this is y and this is y sub 1. Okay. Oh, sorry, x. Okay. So the way we get our rise, okay, if you remember, this is our rise. We would subtract our 2y coordinates, right? So we would go y minus, let's get the coordinates of this point. The coordinates for this point are x and y1, okay? So to get our rise, we would take the difference in y. We would go y minus y1 to get our rise. To get our run, which is this, we would take the difference in x. So we would say x minus x1 to get our run. Okay, so getting our rise and our run gives us our slope. All right, so when it says here that we can substitute our coordinates x, y, and x sub 1 and y sub 1 into this formula, well then what we get now is, okay, so x and y get substituted into x2 and y2. So we have x and y here. And our coordinates x1 and y1 goes into x1 and y1 over here. So it stays as x1 and y1. So this formula then is the slope of this particular line right here. Okay. So we're going to take that now. All right. So I'll just rewrite it over here. And we are going to manipulate it algebraically to arrive at our formula that we want. Okay, so how are we going to do that? Well, we're going to multiply both sides of our equation by x minus x sub 1. And why are we doing that? Well, because we want to eliminate our fraction, right? So we want to get rid of our denominator here so we can reduce, right? We're reducing. So when we do that, the resulting equation is going to be m times x minus x sub 1, which is equal to y minus y sub 1. Okay, so all I've done on the left is I've rearranged my m and my x minus x sub 1. So I just put m first and then x minus x sub 1. Okay, so this is the slope point form of our equation. Okay, but generally the way we write it is as y minus y sub 1 equals m times x minus x sub 1. Okay, so we usually put our y first and then our x is second. This is what you would see on any formula sheet. Okay, so this concludes our introductory video.